The psychology of isolation, preparing astronauts for deep space. Ever wondered how astronauts cope with the extreme isolation of space? Astronaut isolation training is a rigorous process designed to fortify their minds and bodies for the unique challenges of long-duration space missions. This isn't just about surviving, it's about thriving in the face of the unknown. Space missions, particularly those venturing to the Moon, Mars, or extended stays on the International Space Station, ISS, present profound psychological challenges. Astronauts face prolonged social isolation, confinement, and the inherent stresses of operating in a high-stakes environment. Isolation training serves as a critical tool to prepare them for these realities. The primary goals are multifaceted: to build team cohesion, foster mental resilience, and equip astronauts with effective coping strategies. By simulating the stressors of space travel, we can identify vulnerabilities and develop proactive interventions. This ensures mission success and safeguards the well-being of the crew. To replicate the harsh realities of space, various specialized environments are utilized. NASA's NEMO, NASA Extreme Environment Mission Operations, places astronauts in an underwater habitat, mimicking the isolation and operational constraints of space. The underwater environment simulates weightlessness and requires teamwork in a confined space. HERA, Human Exploration Research Analog, offers a confined module designed to emulate the conditions of Mars or Moon missions. This includes limited resources, communication delays, and simulated mission tasks. Furthermore, Antarctic research stations, with their extreme isolation and harsh conditions, are leveraged by ESA and other space agencies. Projects like Mars 500 and Sirius provide long-term simulations of Mars missions within sealed environments. These extended simulations, lasting hundreds of days, offer invaluable insights into the long-term psychological effects of isolation. The duration of isolation training varies significantly, ranging from a few days to over 500 days, depending on the specific goals of the mission simulation. The Mars 500 project, lasting 520 days, stands as the longest continuous simulation of a Mars mission. The length of the simulation is crucial. Short-term isolation may reveal initial reactions, but long-term simulations uncover deeper psychological shifts and coping mechanisms. This data is vital for understanding the sustained impact of isolation on cognitive function, emotional stability, and interpersonal dynamics. The psychological focus of isolation training encompasses a range of challenges. Monotony, sensory deprivation, and the absence of natural light can significantly impact mood and cognitive performance. Interpersonal conflicts, exacerbated by tight quarters and high-pressure situations, are also a major concern. Delayed communication, simulating the real-time lag experience during missions to Mars, e.g., 20-plus minutes, adds another layer of complexity. To mitigate these challenges, various support mechanisms are employed, including journaling, therapy bots, mindfulness techniques, and virtual reality environments. These tools provide astronauts with outlets for emotional expression and stress management. Training exercises are designed to push astronauts to their limits. Role-playing emergency scenarios tests their ability to react under pressure. Limited supplies and artificial schedules simulate the resource constraints of space travel. Sleep cycle disruption, mimicking the irregular schedules of orbital or planetary operations, further challenges their adaptability. Leadership skills are tested under stress, and decision-making abilities are honed with minimal external support. These exercises provide a realistic preview of the challenges they will face in space. Constant data collection is a cornerstone of isolation training. Physiological data, such as heart rate, cortisol levels, and sleep patterns, are continuously monitored. Voice tone analysis and group dynamic assessments provide insights into emotional states and interpersonal relationships. Sophisticated algorithms are used to detect early signs of stress or emotional fatigue. Confidential psychological support is available, although privacy may be limited due to mission safety concerns. This data-driven approach allows for proactive intervention and personalized support. Isolation training offers numerous benefits. It helps identify personality traits best suited for deep space travel. It enhances teamwork, patience, and conflict resolution skills. Perhaps most importantly, it provides invaluable insights for designing better spacecraft, refining crew protocols, and developing effective countermeasures against the psychological challenges of space exploration. The knowledge gained from these simulations informs the design of spacecraft environments, communication protocols, and mental health support systems. As we venture further into the cosmos, understanding and mitigating the psychological effects of isolation will be paramount to mission success and the well-being of our astronauts. Ready to delve deeper into the fascinating world of space psychology? Explore NASA's website for detailed reports on isolation studies, research the psychological profiles of astronauts, and consider supporting organizations dedicated to space exploration and mental health research. Your curiosity can fuel the future of space travel.